Hello. This is Nicholas, and I'm going to be doing a video on, it's called the Superposition Principle, and mainly the undetermined coefficients, the method of undetermined coefficients. In the previous videos that I've posted, I've mentioned how to solve any equation of the form ay double prime plus by prime plus cy equals 0. And I went through all three cases for this specific differential equation. And this is a homogeneous of order 0, a homogeneous second order linear differential equation. The method of undetermined coefficients concerns with functions, differential equations of the form ay double prime plus by prime plus cy, but not equal to 0, equal to some combination of sines, cosines, e's, and powers. So, as an example, let's consider y double prime plus 3y prime plus 2y equals e to the 4t. So the idea is that if I can, using the superposition principle, if I can come up with the solution, I'll call it y sub h, meaning h for homogeneous, the solution to the differential equation y double prime plus 3y prime plus 2y equals 0, and then add that with y sub p, where y sub p is just one particular solution to this differential equation, then that sum will give me my desired, it's of t, my desired general solution. And so the reason why this is true is because it's really the superposition principle. If I have a equation here and I have an equation here, and notice that 0 plus e to the 4t is e to the 4t. So what the superposition principle says in general is that if y sub 1 is a solution to ay double prime plus by prime plus cy is f sub 1 of t. In this case, f sub 1 of t is e to the 4t. And y sub 2 is a solution to ay double prime plus by prime plus cy is f sub 2 of t. Then just any linear combination of y sub 1 and y sub 2, in other words, k sub 1 y sub 1 plus k sub 2 y sub 2, is going to be a solution to the differential equation ay double prime plus by prime plus cy equals, and then any linear combination of f sub 1 and f sub 2. In other words, kf sub 1 of x plus k sub 2 f sub 2 of x. I thought I was running out of room. Let me rewrite that. Plus k sub 2 f sub 2 of x. So, and here f sub 2 of x is equal to 0. So, again, this is what the superposition principle says. So if f sub 2 is equal to 0, then, and y sub 2 is a solution to that part of the equation where f of sub 2 of t is just 0, then any linear combination of y sub 1 and y sub 2 will be the general solution. So by this principle, we can add the solution to the homogeneous equation and then one particular solution to the general, or to the, to the equation not equal to 0, and we can get our general solution. And a proof of this superposition principle is really pretty easy. If you say that k sub 1 y sub 1 plus k sub 2 y sub 2 is a solution to that differential equation, then that would mean that if I plug in k sub 1 y sub 1 plus k sub 2 y sub 2 in for y prime, and y double prime, I would get a times k sub 1 y sub 1 plus k sub 2 y sub 2 double prime plus b times k sub 1 y sub 1 plus k sub 2 y sub 2 prime plus c times k sub 1 y sub 1 plus k sub 2 y sub 2. And that's going to be equal to, I can do some kind of rearranging here, k sub 1, now I have a y sub 1 double prime, a b y sub 1 prime, and a c y sub 1. So I can make that a y sub 1 double prime plus b y sub 1 prime plus c y plus k sub 2 times, now I have a y sub 2 double prime, a b y sub 2 prime, and a c y sub 2. So that's a y sub 2 double prime plus b y sub 2 prime plus c y sub 2, which this is just f sub 1 of t, and the second is just f sub 2 of t, and that completes the proof. So here we are just letting f sub 2 of t be equal to 0, so we can add the two equations together, the two particular solutions together, since, it really just comes down to that 0 there. So now, the method of undetermined coefficients basically picks an educated guess at what the particular solution would be. The homogeneous solution is really easy, right? We've already done that, and we should probably find that first. It's y double prime plus 3y prime plus 2y equals 0. So the auxiliary equation is r squared plus 3r plus 2 equals 0. So r plus 2 times r plus 1 equals 0. And r is equal to -2 and -1. And so y sub h, the solution to the homogeneous equation, is c sub 1 e to the -2x plus c sub 2 e to the -x. And that's the homogeneous solution. Now, the particular solution is where the method of undetermined coefficients comes in. So we had y double prime plus 3y prime plus 2y equal to, I think it was just e to the 4t. E to the 4t. So if you just kind of examine this differential equation here, you would notice, I hope, that the solution to it has to be another exponential function, another e to the rx, say. Because if it weren't, in other words, if the solution y sub p were not in the form a e to the 4t, then nothing would cancel out to give us a 4t. If you guessed, for example, that the solution was going to be like, I don't know, cosine of xt or something, that wouldn't make sense, because the cosines and the sines, when you differentiate, they would never just cancel out, and we would just be left with the e to the 4t. So this is the guess here, is that the solution is in the form a e to the 4t. And now it just comes down to finding what a is. So when we differentiate y sub p, we get 4a e to the 4t we differentiate it again, we get 16a e to the 4t. And if we plug that in, 16a e to the 4t plus 3 times the 4, so that's 12a e to the 4t plus 2a e to the 4t. That's just e to the 4t. So if I pull out an e to the 4t, e to the 4t times, we have a 16a, a 12a, and a 2a. So 16 plus 12 is 28. Add the 2, that's 30a. It needs to be e to the 4t. And just, well, we can divide out by e to the 4t since it's never 0. And we get that 30a is equal to 1. So a needs to be 1/30. And so then y sub p, the particular solution, is 1/30 e to the 4t. So the general solution then is y equals the homogeneous solution plus the particular solution, which is c sub 1 e to the negative 2x plus c sub 2 e to the negative x plus 1/30 e to the 4x. I changed x to t. It doesn't really matter what variable I use. So that is really that with the undetermined coefficients. I want to bring up a point here, though. Let's say, for example, that I made this 4 here. Oops. A e to the negative 2t. Okay. Then you might just kind of, let me erase this. You might just kind of blindly guess, and you might say, well, the solution then is probably in the form a e to the negative 2t. And I want to do the computations because, well, no, actually, let me do it. Think of it like this. If you guess the particular solution is a e to the negative 2t, you would be mistaken because that isn't true. Because look at here. This guess that you've made is precisely the homogeneous solution, of course, where c sub 2 is equal to 0. But in other words, this point, this here, and this here are the same thing. A and c sub 1 are both constant. So when you plug this in to this equation, you better get 0. You're not going to get e to the negative 2t, because this is the solution to the equation when it does equal 0. So you can't guess a e to the negative 2t. And in general, when you want to check this stuff, just look at your y sub p guess and your y sub h, and you just need to ask yourself, are my two guesses or solutions, are they linearly independent? In other words, can one not be written as a scalar multiple of the other? And in this case, they are not linearly independent, they're linearly dependent, because if c sub 2 is equal to 0, then y sub p times c sub 1 over a, where that's just a constant, c sub 1 over a times y sub p is just c sub 1 e to the negative 2x, which is precisely that solution there. So you need to check your y sub p guess for linear independence for your homogeneous solution. So it's always best to get your homogeneous solution first. If they are linearly dependent, like how they are here, what you can do is just multiply. We need to multiply by something to make them linearly independent. And that something that we multiply by, it tends to be just a factor of t. If we just multiply by a factor of t in our y sub p guess, then these two things are linearly independent because of this t that we multiplied by. Now, none of these two terms don't have a t or any factor of a t, so they can't just be scalar multiples of each other because they're missing a variable. They're missing that t. So basically, just look at the two, and if they match up, then they're linearly dependent. If they don't, then they're linearly independent. Now, to go about this differential equation, solving this one is a little more tedious. It's very much the same process because, you're doing the same thing, but the thing that just kind of stinks is that now you have the product rule to deal with. So y sub p prime is, well, let's make it a times now e to the negative 2t minus 2t e to the negative 2t. That's y prime, and y double prime is a times, now I differentiate that's minus 2e to the minus 2t, and we have a minus 2e to the minus 2t plus 4t e to the minus 2t, and so y sub p double prime, minus 2 and a minus 2, that's a minus 4, so we can make that 4a times t e to the negative 2t minus e to the negative 2t. Okay, and now we just plug that stuff in. So, and I'm going to fill it all out as well. So, y double prime, that's 4a t e to the negative 2t minus 4a e to the negative 2t. Now we plug in 3 times y prime. That's plus 3a e to the negative 2t minus 6a t e to the negative 2t. Now we plug in 2 times y, which is plus a 2a e to the negative 2t times t, and that's got to be equal to e to the negative 2t. Now I'm going to combine my like terms. It really just becomes an algebra problem. So we te to the negative 2t, te negative 2t, and te negative 2t. And then this is just a e to the negative 2t and e to the negative 2t. So I have a 4, a minus 6, and then a plus 2. Oh, 4 minus 6 is negative 2 plus 2. That all goes away. That's very nice. And then now this is a minus a e to the negative 2t is equal to e to the negative 2t. This is a 1 right here, so that means that negative a is equal to 1, or in other words, a is equal to negative 1. So our y sub p, our particular solution, is negative t is, let me write it better, negative t e to the negative 2t. And for this particular equation, y, our general solution, is c sub 1 e to the negative 2t plus c sub 2 e to the negative t minus t e to the negative 2t. And that would be the solution there. Now I'm going to consider a couple more cases here. Let's use the same differential equation. And let's do a polynomial instead. So let's say that's t cubed. So what would we guess for our, well, first of all, let's find we know already the y sub h, that hasn't changed. That's still c sub 1 e to the negative 2x plus c sub 2 e to the negative x. Now what would we guess for our y sub p? Well, we should probably guess a cubic, right? So any equation of the form ax cubed plus bx squared plus cx plus d would be our y sub p guess. And if this were a t to the fourth, I would write down the general equation for a quartic, or if it were just t squared, it would write the general equation for a quadratic. Ax squared plus bx plus c. And so then y sub p prime is 3ax squared plus 2bx plus c and y sub p double prime is 6ax plus 2b. And so now we plug that stuff in. We get 6ax plus 2b, or not 2b, just kidding. 6ax plus 2b. Now we add that with 3 times y prime. So that's plus 9ax squared plus 6bx plus 3c. Then we add that to 2 times y sub p. Oh boy. I might need a little more room. Move that over there. So that's, oh, not equals yet. Plus 2ax cubed plus 2bx squared plus 2cx plus 2d. And all that is going to be equal to t cubed. So, like terms. Okay, this is a cube. Oh, why did I do x? Okay, I changed it to x for some reason, so let me change this to... I keep changing it to x, so let me just change this to x. Okay. So, we have x cubed there, and I think that's it. We have x squared, I think that's it. An x, and an x, and I don't know, orange. Constant. Oh, no, I want that there. Okay, so now that means 2ax cubed plus, now we have 9a plus 2b, or not 2b, x squared. Now we have 6a plus 6b plus 2c, so that's 6a plus 6b plus 2c x, and now we have 2b plus 3c plus 2d, so plus 2b plus 3c plus 2d, and all that's x cubed. So that tells me, comparing coefficients here, that 2a needs to be this 1 here. So 2a needs to be equal to 1. A is a half. And then that tells me that 9a plus 2b needs to be equal to 0, right? Because there is no term of degree 2 on the right side. There's really a 0x squared. And so since a is a half, 9 halves is negative 2b. And so then that means b is negative 9/4. Now, 6a plus 6b plus 2c, that also needs to be equal to 0. And so a is a half, so 6 times a half is 3, plus 6b, which is, so that's 6 times negative 9/4. That goes in with a 3 and a 2, so minus 27 over 2. So 3 minus 27 over 2 is negative 2c. So 3 is 6 over 2, and 6 minus 27 should be a negative 21 over 2 is negative 2c, and so c is 21/4. Now, we know also there's no constant term, so 2b plus 3c plus 2d is 0. b is negative 9/4, so that's negative 9/8, plus 3c, so that's plus 63 over 4, yuck. 21, 40, yeah, plus 2d, or so that's negative 2d. So need to multiply 63 by 2. That gives me a 126 over an 8. And 126 minus 9, that's 115 over 8 is negative 2d. And so 115 over negative 115 over 16 is d. So all that good stuff tells us that our particular solution, so what? A was a half, B is negative 9/4, C is 21/4, D is negative 115 over 16. So our y sub p is 1/2 x cubed minus 9/4 x squared plus 21/4 x minus 115 over 16. And so our general solution y to the whole equation would be all that plus c sub 1 e to the negative 2x plus c sub 2 e to the negative x. And so you can see it gets messy. The algebra can get really messy. I do have one more case to consider, and that's with sines and cosines. So let's consider the same equation. Let's say that's equal to sine of 2x. Our y sub h is still c sub 1 e to the negative 2x plus c sub 2 e to the negative x. And now our y sub p, our guess, it shouldn't just be of the form a sine of 2x, because when we differentiate the sine, we're going to get a cosine, we're going to have negative cosines. So it should be a linear combination of sine and cosine of 2x. In other words, a sine of 2x plus b cosine of 2x. Because we need this part of cosine to cancel out with when we differentiate the y sub p. So y sub p prime is, oh, and by the way, if this were a sine of 3x, then this and this would have been a sine of 3x. Whatever the angle inside was, you need that same multiple for your guess. So this is 2a, when we differentiate 2a cosine 2x plus, or minus 2b, or not to be, sine of 2x. And so y sub p double prime is negative 4a sine of 2x minus 4b cosine of 2x. And so now, what can we do? Well, I can say that when I plug this in, negative 4a sine of 2x minus 4b cosine of 2x. Okay, that's y double prime. Now I add 3 y primes, so that's plus 6a cosine 2x minus 6b sine 2x. And now I add, oh, this should have been a 2y, whoopsies. Now I add 2 times our y sub p, which is plus 2a sine 2x plus 2b cosine 2x. And that's all equal to the sine of 2x. So there's only 2 types of terms here. There's one with the sine and one with the cosine. This is a sine. That's not a sine. This is a sine. This is a sine. Cosine, cosine, cosine. So now negative 4a minus 6b plus 2a. So that's negative 2a minus 6b sine 2x. And now we have negative 4b plus 6a plus 2b. So that's plus 6a minus 2b cosine 2x needs to be the sine of 2x. And so that tells me that this part, this 6a minus 2b, needs to be equal to 0 since there is no cosine over here. And so in other words, 6a is equal to 2b, or b is equal to 3a. And now I know that this negative 2a minus 6b needs to be equal to 1 because this is a 1 sine 2x. And the 6b I can replace with 18a. So negative 2a minus 18a is 1, or negative 20a is 1, or a is negative 1/20. And so if a is negative 1/20, then that means b is 3 times that, or negative 3/20. And so y sub p is, what was our form? It was a sine 2x. So negative 1/20 sine 2x minus 3/20 cosine of 2x. And we would just take that and then add c sub 1 e to the negative 2x plus c sub 2 e to the negative x. And that would give us our general solution. Okay, a couple other things I need to talk about. If I'm not going to go through the whole algebra again, but I'm going to talk about what we should guess for our y sub p sum. Let's say, for example, we still have the same y double prime plus 3y prime plus 2y. But let's say we had e to the 4t times the sine of 3t. What should we guess for our y sub p? We should guess, well, we're going to need a sine 3t, and we're going to need a cosine 3t, for sure. And we're going to need a linear combination of sines and cosines. And of course, that all has to be multiplied by e to the 4t, because if it weren't, then we would have no chance of getting this e to the 4t. And so that should be your y sub p guess for that particular function. If, say, oh, this will get messy, but let's say we added in a t squared here, then our y sub p guess should be, of course, we still have the a sine 3x plus b cosine 3x. Whenever you got a sine, or, and by the way, if let's replace it actually, just for emphasis. Even if this were a cosine instead of a sine, the guess would still be the same. It's a sine 3x plus b cosine 3x. We're still multiplying by e to the 4t, but we also need to multiply by a quadratic, right? To get this t squared here. So, oh, I can't use a, I already used it. Plus cx squared plus dx plus e. And that would get pretty darn messy to algebraically solve, but it could be done, and you know what to guess for y sub p, and it really just comes down to an algebra problem now. And so I think that really covers all of the possible cases. I do just want to say, though, that this method of undetermined coefficients, again, how I'm getting these guesses is I'm looking at my equation, from the beginning. You would have to have this sort of stuff in order to, when you differentiate and add and multiply and all this stuff, get something like this. But it only works for these, predictable and cyclic type derivatives. So the undetermined coefficients, the method of undetermined coefficients, really only works for a limited class of functions. It only will work this is the this type of situation is the most general situation, but it only works, you know, for e to some power, cosine or sine to, you know, inputting some angle, and t to some power. That's the maximum capability of the undetermined coefficients, because any other type of function, when you differentiate it, it's not predictable or cyclic or follows some sort of nice pattern like e's and sines and cosines and powers. Oh, and one other thing I would like to say is just to remind you, if instead I change this, you know, the equation is still the same, but if I changed it to a, let's say a 2y plus 1y, then my auxiliary equation for the homogeneous solution would be r plus 1 squared equals 0, or r is equal to -1 repeated. So I mean, don't get afraid with that or anything. That all that means is that the homogeneous solution is c sub 1 e to the negative x plus c sub 2 x e to the negative x. And I have shown that before in another video with reduction of orders, but you know, if you've got a repeated thing, don't worry about it. Or if you have something that's complex, I mean, the procedure for finding y sub h is still the